So today,
You know,
today we are going to see the what are all the process running inside the server, how to check that, and how to check the memory usage and CPU usage, and how to check the ports and etc. So why do we need to check all those things? First, let me come to the point of process. Process. What is the process? Process is nothing but a program or a application running inside your computer. Say for example, you take your mobile. So inside your mobile, there's a lot of application will be running, right? So in that currently, what are all the applications running in your mobile? How do you know? You go to that settings and you went to the applications and you can check that what are the currently running applications, right? So in the system as well, we can check the same thing. What are all the process or what are the application that are currently running inside the Ubuntu server? So for that purpose, only we are going to check the process. So it's same like mobile. And why do we need to check the system resources? System resources like RAM and CPU. So say for example, if you are opening application in your mobile, that application is very slow or the application is hanging sometime. So you need to first you need to check the RAM. What is the RAM used by the application, and what are the other processes that are using the high amount of RAM. So by analyzing that, you will come to know this is application using the lot of RAM, and you will sort it out that slowness or the hanging by closing the application or by restarting the mobile phone. Same like we can check in the Linux server as well. Okay, so I'm going to show how do you do that. So say for example, if you are placed in some company and your manager or your team lead is asking you to get the processor list that are currently running in the system, or get the top CPU, top used CPU application, or top CPU memory. So how do you get that? So that we are going to see now. Okay, I'm sharing my screen now. Please let me know once you are able to see that. Screen is visible to you all.
yes.
Okay. So first, let's see the process. How to check the process running inside the computer. So for that, we are going to use the command called PS. So PS is nothing but a process status. So by issuing the PS space hyphen PF, it will give you the all the processes that are currently running inside the Ubuntu server. The UID is the username or user ID, something like that, and the PID is reference to the process ID. Every process is having its own process ID. It is a numerical number. The process is attached with the process ID, and how much the time is how much time the process is from the start. It is running from its start time, and the CMD is the what is the command that the process is using to run the application. Okay, so this is what the tabular column here. So you need to understand like in that way. Okay, now the PS space hyphen EF is giving the all the E referring the all the process, and F is representing the full format, the command including the command it will give. Okay, we're using the PS space hyphen EF. And one more way to see the same thing by using the command PS space hyphen AUX. It will also give you the same output. It will give some additional information of how much CPU and how much memory that process is currently using. Say for example, if you take that S bin and in it the splash, that process is taking 0.2 percentage of memory and 0.7 percentage of CPU. So this is the process ID for the command. So by issuing this command, you will come to know what are the process currently running inside the system. Okay. So, so what are the various options that are available in the PS command? So if you are issuing the PS space hyphen F and space hyphen U and followed by the username. Username currently I have logged into Ubuntu. So it will give you the sorry. Okay. So it will give you the all the list of processes that are running under the user. What are the users that are currently running the process? It will give you all the users process information. Okay. Then if you want to know the particular process, if you want to know, say for example, if I am running the Postgres inside the machine, so if you want to check whether the Postgres is running or not inside the system, how we are going to check that? So by using the PS command EF, and you need to filter it out, right, for to get the specific process. So you need to filter it out by using the pipe symbol and putting the grep command. And if you know the process name, or what if you know the process name, if you know the application name, you just type the application name or the process name here. Let's say example, I'm typing Postgres because I know Postgres is running in my system, so I'm typing the Postgres. Okay, so you'll get the output like this. So this is the main process ID of the Postgres, and these are the child process. Okay, the 1038 and 1039 is there are two Postgres instances running in my system. The one is a Postgres 11 and another one is a Postgres 12. So this is the main thread, the main process ID of the Postgres 1038 is the main process, and these are all the sub process of the 1038, and these are all the sub PID of the 1039. You need to understand in that way. Okay, so these are all the process running inside my computer which is related to the Postgres database. Okay, so this is a command to check the particular process whether it is running inside your system or not. Okay, any questions or any doubts? If you have any doubts in that, please post your questions in the question and answer column. Okay, the next topic I'm going to take is how to check the CPU and memory usage. As I told you earlier, if some of the application, why do we check that? In as I said earlier, in your mobile, if your application is getting hanged or it is getting slow, then you need to check out what are the amount of the memory is being used by the application or something like that. So for that purpose, we are going to analyzing it. So for doing that, we are going to use the top command. Okay, in Linux, we are going to use the top command to know the usage of CPU and memory. So by typing the top, we'll get the output like this. In the top, it will show you the information of how much of the time the system is got up. It is up and running on last 17 minutes, and how many users are connected. So currently, 2 users are connected is, and what is the average load for the system? Currently, it is in 0.4% only, something like that. So the second column it represents the tasks, total number of tasks that are running in my system, and two running. This is the total number of tasks, two running, and 184 is in sleeping mode. Okay. So the third is the one, the CPU percentage. So currently my system is using the 3.6% of the CPU. This is the total CPU, and this will be, sorry, the 2.5 is the user. What are the application which is related to the user? That process is taking this much CPU. That user's process. Okay, this is the second column is the 2.9 is the system processor is taking 3.3% of the CPU, and my system is ideal of 90% of the CPU is ideal currently right now. Okay. Then the third column is the it represents the memory. It will all represent in the KB. So currently my system is having this much KB of the system. Okay, this much KB of the memory. So in the below you can see the PID and what is the user that is running the process, and what is the CPU usage, and this will give you the detail explanation. Okay, so what is the command which is used by the process ID, and which user is running the process, something like that. Okay, so if you want to sort sort it by the memory, you need to press the shift MP. So it will sort it out the memory wise. So what are the topmost process that are used by the memory? So it will give, if you see here, it will give you like that, the descending order. Okay. So by doing the top command, you can see the CPU and power. Okay. Next, we'll see the disk usage command. So in Windows, you will see some C colon or D colon or E colon. In that, you will have this much GB of free space out of 500 GB, something like that. You can see, right? So in your mobile also, you can see the how much free space is there in your mobile. Using the file explorer, you can see, right? So in Linux also, we can see by doing the command. So for that, we are going to use the df command. Okay. By entering this will give you the output like this. So with this command, you will not able to read because I'll give the output like a kilobyte. So you will not, it will not be in the human readable format. So for the df space hyphen h command will give you the human readable format. If you see the difference between, it will be giving the value as a MB and GB as well. So the df space hyphen h represents the human readable format. So what are the file system that are available in my system, and what is the total size, and what is the usage, and how much space is available currently now. So we need to understand in that way, and what is the partition it is mounted on. So these are the partitions. I have inserted a mount partition or a external drive. So this is the mounted device name, and this is the file system name. Okay. The next command we are going to see is the netstat command. Netstat command is used for to check what are the ports are currently listening inside the server. Okay, so what is the port number? Port number is nothing but a logical address. It will be attached in each of the application or each of the process in a networking or in a to communicate with the user. So that is the port. So in computer system, there are around 65,000 something port will be available. So each process will be attaching with the some port number. Without port number, you cannot communicate with the application. So for that only we are using the port number. So we can know the port number by issuing the command called netstat. Okay. So first we will see for issuing the netstat command, you need to install the net-tool command first. Without installing this tool, you will not use the netstat command. So this is a prerequisite for using the netstat command. Okay. So I have already installed, so I don't do the installation now. Let me directly go to the command. The first thing is so to list all the ports that are currently listening in my system. So for that, I'm going to use the system A. So it will give all the ports that are listening inside my server. Okay. So these are all the protocols called Unix, and the state it is listening. It is currently all. It is some of them are in listening state, some of them are in connected state. So these are the port number. Okay. Next, I'm going to show you how to display the TCP and UDP connections alone. In computer, there will be a lot of protocols we used to build the application. So the TCP and UDP connections are mainly used in the system. So we are going to identify those ports. For that, I'm going to use the command netstat -at. This will give you the all TCP protocol and UDP protocol in that. So currently, these are the TCP ports that are running, that are listening in my system. Okay, these are the state, and this is accessing from a local address. This is the foreign address. Okay, this is the port number. Okay, next, if you want to know the specific applications port number, say for example, I have already shown in my system, I have already run the Postgres. So if you want to know the Postgres, what is the port being used by Postgres, you just need to issue the command type, and you will filter it out for the specific thing. So you need to type the program name or the application name here. So for getting the port number, you need to issue the command with the administrator privileges. So say for example, Postgres is listening in my system. This is the port number that is being used by Postgres 5432. And as I told already, there are two instances of Postgres running in my system. One is running on 5432 and one is running on 5433. Okay, so like that you can come to know. So that's all from my side. I will over to you, Kaushik.
Thanks, Krishnan. Thanks for the session. I think everybody learned how to start a process, how to see the attributes associated to the process. How do you see how what is the amount of memory used by each process? How do you see the CPU usage of all these process? So basically, we have been talking a lot about the processes in the Linux operating system. So in today's now, in what we will see is we will see how Linux or Unix, for that matter, manages memory. Okay. CPU is another part. Okay, we will not get into the CPU part. Usually, the operating system mainly manages the memory. Okay. CPU is basically the hardware part. I mean, it's basically the processing capacity. Okay, the operating system does manage the processes, the processor, but mainly we are going to talk about how this one manages the memory. Okay, so let's go into the topic. So yesterday we had seen, what is Linux, and what is the usage of Linux, how why is Linux being used as an operating system, right? Krishnan, can you mute? Thank you. So we have seen, like, why do we use Linux as an operating system, what are the benefits of it, what are some interesting facts about Linux. So today, if you look at the operating system, the structure of Linux. Sorry, I think I haven't shared the screen. Just a minute. I'm sharing the screen. Yeah. So what you could see is you could now launch. Okay. So now what I'm going to do is I'm going to open the slideshow. Right. So if you look at my screen, if you look at the operating system, there are a lot of applications running on top of the operating system, right? And what you see is in the system mode, okay, that is in the system mode, there are certain programs running, okay, and these programs could be your system services. It's a file system. Okay, Linux file system is very unique when compared to Windows. Unix treats everything as a file, meaning even the desktop is also a file for it. A printer is also a file for it. Okay, that is hardware and software. Both are files. Okay, suppose you install a software, that is also a file. You install a device, that is also a file for Linux. So Linux file system is slightly different when compared to Windows. We will talk much about that Linux system. Where are each of these components saved? All these things we will see. Okay. Now, what is happening is there is a process. There are a lot of processes running. Okay. Now, Postgres is a process. Okay. Postgres. Now, just like Krishnan sir showed you that there is a Postgres. Postgres is a process. Now, there is Tomcat. That is a process. Okay. Tomcat or any server, it's a process. If you take a Windows, right? Sorry, the MS Word. MS Word is a process. Okay. Okay. I want to ask you something. Okay. Now, for example, let's say your computer, okay, you have, let's say you created a document. Usually, by what you will create a document? You will create a document by using MS Word. Okay. Now, you will send that as an email to your friend. Your friend will download that file. Automatically, do you see the file with the MS Word icon? Yes or no? When you send a file to your friend, maybe an image or anything, right? So you're sending from your file to your friend. The moment you send a Word file, he is seeing it as MS Word. And when you double click on it, it will automatically opening using MS Word. How is it happening? How is it happening? Any idea on how is it happening, or why is it happening that way? Why is it happening, or how is it actually happening? Now, just now, Krishnan sir has told us about something called as ports. Ports. Okay, so if you look at a PC or any operating system, you have 65,356 ports. Okay, in a machine there will be those many ports. Now a port is nothing but, now imagine like this. You know what is a mail? Okay, now I'm just asking you a question. Suppose you have a Type C USB port. Okay, Type C USB port, and then you have a previous one. Before Type C, what was that USB type? Before now you have Type C, right? A bigger one. Okay. Now before that there used to be another slightly smaller one. What do you call that? What type is that? Anybody knows that? Okay. Let us call it as Type B. Okay. Can you insert a Type C port in a Type B port? Can you insert that? Can you insert a Type B port in a Type C port? It is not possible, right? It is not possible. Why? Because it only matches that port, right? Similarly, I don't know how many of nowadays you don't see a desktop. If you go back to if you see the back side of a desktop, do you see a lot of ports? There will be one port for mouse, one port for keyboard, one port for printer. Have you seen those ports? And that ports are of two types. One is a male port and a female port. It's a male port and a female port, right? If you look at the ports, right? Ports, male and female, right? So you have a male port. Okay, so if there are holes, it's basically a female port, and this is it's a male port, right? So a desktop will have these kind of things. You can only, suppose if this has 21 pins, you can only insert something which has exactly those many number of pins. There is no way you can connect wrongly. One of the beauty of the desktops was the desktops wire wherein the ports were made in such a way that you can only connect the right one. There is no way you can connect the wrong one. Okay. Similarly, like this, software applications also have ports. Okay. That is, every software will have one port number. Okay. And only that port number software can open it. So when you create a Word file has a port number. Word file has a port number. So when it goes to the other machine, the file along with the port number is sent. Okay, file has something called as a metadata. That is some details about the file. What is metadata? What is metadata? Data about the data, right? Suppose there is a file has some metadata. What are the metadata for a file? It will have the name, author, size, right? You'll have size. Then it will also have a port number. Okay. Now in that machine, if there is a software with that port number, only then you will be able to open. Suppose I send you a Word file, and if you don't have Word in your machine, will you be able to open? If I send you a Word file, and if you don't have Word installed on your machine, will you be able to open that Word file? No, right? Maybe you can upload it to a Google Drive and open it, but from your machine you cannot open it. Basically, there's a port number associated, right? So every application has a port number, and only that particular application with that port number can access it. Others cannot access it. Okay, that is with respect to the ports. Okay, coming back to the concepts of operating system. So there are a lot of processes running. Each process will have a port number. Now, the operating system has a very big challenge. The challenge is managing the memory. Okay, there are two types of memory. One is called main memory or primary memory, and the other one is called secondary memory. Now, in your machine, okay, in your laptop or in your computer, you have two things. One is a RAM and one is a hard drive. Which one is the primary memory? Which one is the secondary memory? In your machine, you have RAM, okay, and you have your hard disk. Which one is the primary memory? Which one is the secondary memory? In your machine, very, very fundamental question. In your laptop, you have hard drive, you have your RAM. Which is the primary memory and which is the secondary memory? Okay. Many people have said RAM is the primary memory. Okay, correct. Now, suppose you are creating a program in Java. Okay, you are creating a program in Java. This program, the program file, the source code, will it be in what do you call hard drive or it will be on RAM? No, somebody says hard drive as primary. Sorry, no, hard drive is not primary. Okay, RAM is the primary memory. Okay, RAM is the primary memory. Hard drive is the secondary memory. Remember, RAM is the primary memory. Okay, hard drive is the secondary memory. Okay. Now, whenever you are storing a program, the program will be stored in the secondary memory. Whenever the program is executing, what will happen? Whenever the program is executing, it will be executed on RAM, right? The execution happens on RAM. Very good, Syed. Very good, right? So the execution happens on the RAM. Okay. Now in your computer, there are so many programs running. Now, if all the programs, I mean, even if you take your mobile phone, okay, there is a WhatsApp running in the background. There is your Telegram running. Your what do you call it? Any other application, right? It could be some learning app or some software, right? Google, Gmail is all these are running. So when all these are running, your one RAM is not enough. For example, in my laptop, I have an 8 GB RAM machine. So here I am running. See, if you look at my screen, okay, I am running Chrome, right? I have a PowerPoint here. I have a Word here. I have some other program running here. I have Zoom running here. Like that, I am running several programs. Now, how is the RAM managing all these things? How is this all programs running parallelly on my machine? Okay, so that is where comes the concept of memory management. That is where you get the concept of memory management. So, how is the operating system managing it? It is very important to understand this concept because whenever we are building very high performance software, we need to understand or we need to know how to make the system run faster. Okay, so it is very important to understand this. Now you can see that main memory, it is the internal memory that is only accessible to the CPU directly. Only CPU can access main memory. A very, very important question. A hard disk cannot access RAM. Hard disk cannot access RAM. Only the processor can access the RAM. Okay. Secondary memory, it is a permanent storage and non-volatile. Most computers use disks to store both large programs and data. Now, here the OS has some responsibilities. Okay. It maintains and tracks which part of memory is used and by which process. So the OS will know, suppose if you have a RAM, right? In that, which part of the RAM is being used by what program? How to load a new program when you have a problem? OS allocates memory when needed and should deallocate the space if it is not needed. This is a very, very important problem. Okay. Okay, we will discuss about all these problems. Then comes the responsibility of the secondary memory. It tracks for free space on the disk. So wherever there is a free space, the files will be stored. So this is basically then you have something called as a command interpreter. It's a program that interprets control statements. Its function is to get and execute the next command statement. Okay, so there will be a command interpreter in our operating system, which will maintain a queue of programs that we have to run. Okay, it will look for what program should be loaded next and how it has to be loaded. Now, for all these things, there is a process management that is defined. Okay, a process is defined as a program in execution. Suppose if a program is running, that is called as a process. Okay, suppose in your machine, you have a C program running, you have a Java program running. So C program is a process, Java program is a process. Okay, each process will require some amount of CPU time, some amount of memory, and some amount of IO devices. Okay, so if there is a program, suppose you have written a C program, to print something. Okay, so it requires some CPU, it requires some memory, it requires connection to the printer, right? Now, the responsibility of operating system for process management is it should create the process and delete the process. It should create the process and delete the process. Process suspension and resumption. Suppose if the process, see, sometimes it is not always so. Okay, now in your mobile phone, suppose you all use mobile phone, right? Suppose you have WhatsApp. Okay, your friend sent a message in WhatsApp, and another friend sent a message on Telegram. Will you completely close the WhatsApp or directly switch to Telegram? You will completely switch to Telegram, or you will completely close WhatsApp, or you simply switch to Telegram. So when you do a switch, what happens is the WhatsApp process is suspended. That means we will understand what is suspension and resumption. So the WhatsApp process is suspended and Telegram process is started. It resumed. Okay? It is also running in the background. So it got resumed. Okay. So there is something called as it should manage the process. And what it should also do is there are cases where you have to communicate between process. It's called process communication, or it is also called as IPC, inter-process communication, communicating from one process to another process, and process synchronization. Okay. Now, this every process, right, will be in any of these 5 status. It will be new, it will be ready to execute. Okay, it will be running, or it is waiting, or exit. Now we will understand what is this. Suppose there is a program on your machine. You wrote a program for C language. You wrote a program in C language for factorial. Okay? You wrote a program for C language. Now you have compiled it, right? You have compiled it. So it is ready for execution, right? That is called new. You are not running it. You just compiled it. Compile means it is ready for execution. That is the stage where it is new. Then you run it. When you run it, what happens is immediately it will not go to the RAM. It will not go to the RAM immediately. It will go to the command interpreter. The command interpreter will have a queue. Once you go to the top of that queue, or when you go to the beginning of the queue, right? That is where you come to a ready state. That is where you come to the ready state. When you are in the ready state, what your operating system will do is, there is something called a scheduling algorithm. We will talk about that in some time. Based on the scheduling algorithm, it will check whether you can be allocated whether you are ready to run. If it feels that, okay, this guy can run, then it will set you in a running state. Now, when you are in a running state, what can happen is, suppose you are running a program. Assume that you are running a program. And for running this program, you need to take a printout. Now, what is happening is somebody else has already running a program where the printer is still printing. So what you will be do? You will be in the waiting state. Now, when you are in the waiting state, assume there is a user A who is doing where you are user A. Okay, you are user A. You wrote a code to do some printing. Now your code is running and waiting for the printer. Okay. There was another user B who wrote a program and executed to do some printing. Now that printing is happening. While that printing is happening, the printer ran out of paper, right? So what happens? That process B is still pending, right? And this guy is keeping on waiting, right? This A is still waiting. He is not getting the printer. So what happens at that point? The person who is next in the command interpreter, he will be blocked. He will be blocked. Okay. So there is, just understand this one. Okay. Say for example, let's say you are cooking. Just an example. Let's say you are cooking. When you are cooking, right? You mixed everything. Now you want to put on the gas, but the gas is not free. Somebody else is using that gas. So that when that guy is using the gas, something happened and the wire got cut. The gas tube got cut. So that the previous one will never get cooked. So you will keep waiting. So the next person who is supposed to cook gets blocked. So this is the entire process life cycle. In order to manage this, in order to avoid these unnecessary waiting, in order to avoid this unnecessary timeout, this deadlock and block, we have something called as process scheduling, which we will talk about that in tomorrow's class. Okay. So today we understood what is a process. Okay. Today we understood what is a process. Okay. What are all the various states the process is there. Okay. And what is the part of operating system in this process management. How the process is managed by operating system. So we have seen the life cycle of process, but in order to run this smoothly, we need to look at something called as process scheduling, which we will talk about that in tomorrow's class. A very, very important lesson. Tomorrow we will talk about process scheduling and a very important concept called segmentation and paging. Okay, which is a very, very important concept. Okay, any questions? Any questions?